Today I'm going to talk about software that was tested by monkeys, and I'm not referring to end users. What I mean by banana software, well, bananas are usually harvested when they are green, and they are sold when they are, well, somewhat yellow, but not still ripe, and they ripen at your home, at the end user. And the same is true for too much software today, still, which means that it's the burden of the customer to find all the bugs and report them, and you fix them, and then afterwards, after he bought the software, it ripens as he uses it. And this still happens too much of the time, and we want to see how we can fix that. So, before I start, I want to tell you a story about Bob. This is Bob. Bob, say hello. Bob is a developer. Thanks. Bob is a developer, and just like many of you may know, he has regular releases, and he has a pending release tomorrow. So he wants to release his software, and he still has a bug in it. And because of the release, he wants to fix the bug. And in order to be able to fix the bug, he needs to change the software. And because it is a minor change, and in theory, nothing should happen, but, you know, because protocol requests it, he needs to test his software. I mean, he wouldn't need to, because nothing will break anyway, but yeah, so it adheres to protocol, and lo and behold, when he does the testing, so he has some automated tests, but also some manual testing, and as he does the testing, he finds that there's still another bug, because the software, the change that he made was in the lower level of the software and had some side effects that he didn't think of, so he found another bug. Okay, obviously he wants to fix that bug, which leads to another change, which means another round of testing, and too bad he found yet another bug, and as you can see, this continues for some time. Also he has some automated tests, but as he changes the software, the tests break. And because he is released tomorrow, he just deactivates them, and of course he will reactivate activate them after the release, but for now he just, you know, needs to get the work done. So he just deactivates the automated tests, keeps on manually testing, finds bugs, keeps on fixing the bugs. And the problem is, the longer he tests, and the longer the cycle continues, the more sloppy he gets with testing, right? So, because testing the same stuff again and again. So this is stuff that already works. It's regression testing. He's testing stuff that worked, used to work at least. And so he's testing the same stuff times and again. It's boring, it's exhausting, and it's not really, you know, kind of work that you want to do as a developer. So, you know. But at some point he realizes that it's already quite late. So, okay, he decides, he still finds bugs when testing his software as he continues to fix them. So he decides, okay, we just go back in time, undo everything, use the version control system to roll back all the changes and release with that minor bug that he started with. At which point he realizes that at some point he corrupted his version control system, his state that he wanted to release. Now he panics. And because of this, all he can do is just continue in this cycle of testing and fixing bugs and continue to test. Well, after a full night of coding and testing, he's able to release a version that is not yet fully tested and still contains some known bugs. It's 8 o'clock in the morning, so he decides to take the day off and go home and take a nap of sleep. And of course he will automate tests in the future so that he doesn't need to do as much manual testing. Okay, so this is a story that I've heard. Of course I never experienced that myself, and I'm sure nobody of you ever did. But it's an urban legend that's been told by my uncle. Okay, so a short survey. Who of you ever tested manually? Okay, all of you. And whoever regression tested manually, which means tested something that worked again. Okay. And who liked it? So, okay, nobody likes regression testing. Nobody likes to test stuff that used to work again. And the question that is really behind all this is, why didn't you automate it? Right? At that point in time where it works, where you say, okay, now I tested it once, it works, I just want to keep it that way, why didn't you automate the testing? Well, the answer, of course you all know as well, is that graph, which means that if you do regression testing on the UI level, on the GUI level, you have a lot of additional effort just to get it starting. You need to create a test environment, you select a tool, install it, record some tests or script tests or whatever you do, and you know, that's a lot of additional effort just to get it started. And the saved effort, the effort that you do less, the testing, it only the return on invest, so to say, only gets you only get over time. You reap the earnings of what you do only after. So a rule of thumb is that you need 5 releases that it pays out. If you have a software that you release less than 5 times, you shouldn't start with automation UI testing at all. And of course there's another thing, which is that graph, which means if you want to increase test coverage, which means that you lower the risk of not finding bugs. So the risk that there are bugs that you miss, which means you need more tests. You need more coverage, lowers the risks, and because you have redundancy in those tests, the effort increases unproportionally. And this is another reason why there's a sweet spot, why you don't want to automate everything, right? So we essentially have 2 problems here. Regression testing is a lot of effort, and test automation is also a lot of effort. So there's 2 evils, and you can choose. Okay, so essentially we want automation, and we don't have automation, which means we spend our time testing instead of, you know, doing the real stuff. Which means that we don't have time because we do manual testing. And because we don't have time, we also don't automate because we don't have time to automate. So what we need in, at that point would be something like that, right? Automated automation. At the push of a button, you have automated regression tests. Would be great, right? Okay, I will show you how we can get into the direction of that. So the idea bases on the infinite monkey theory, which essentially says a monkey hitting keys at random on a typewriter for a long enough time will eventually write all works of William Shakespeare. And what monkey testing is about is to replace the typewriter with a computer and let the monkey test. So in order for you to better understand what this means, I brought a monkey with me. Don't be afraid. It looks like this. This is actually working code. You can copy and paste it, execute it, works. And what it does is in an endless loop, it moves the mouse to a random XY coordinate and enters some random string on the keyboard. This is just it. And it looks like this. So I have a video here because, as you see, it was an endless loop, and it takes control of the input. So I would not be able to stop it, and had to hard reset the machine. That's why I created a video. And what it does is, in that case, it tests a website. But with that monkey, you could test anything. You could test your favorite 3D action shooter. You could test Eclipse or Word or whatever it is you like, your personal programming project, whatever. It doesn't matter. You can test it, and it will find bugs eventually. Okay, let it run for a couple of hours, overnight. In the morning, you look at it, and it crashed your software. In that case, we're testing a web application, so the web application will not crash on you because, you know, it's a web application. You will find the errors in the server log. If you go look, you will find errors. But the monkey is not yet perfect. Like, for instance, in that case, we clicked on an external link and stopped testing our web application and started testing the internet. And it's also, the problem is you can't really like extend the monkey easily. So if, for instance, you have a print button, it's going to cost you a lot of money. Or if you want the monkey to log in before it starts testing, you really can't tell it to do so. And also, if it finds a bug, an error, a crash, it's no help. Like, it can't tell you what it did. So you only get X and Y coordinates. So it's hard to understand what happened before the crash. So you only get the diagnostic information that you would get from an end user, essentially, like a stack trace or whatever. But it finds bugs. So this is what's called a dump monkey. And it's already working, but we could make this better. Like, we want a smart monkey, right? Like this. And essentially, it is as easy as that. I also brought a smart monkey with me, and it looks like this. Now we are using Selenium, and essentially open a website and start clicking on link elements and enter text into text fields. And again, this is working code. You can execute it. It will work. But now you can't test your favorite 3D action shooter anymore. You only can test websites, which looks like this. As you can see, the mouse isn't moving because we're inside the browser. And this, again, will find problems, will find bugs. And this time, you can log what happened. You can tell the monkey, OK, log what did you do? What link did you click? What strings did you enter? And stuff like that. And you also can extend it easily. Like you say, OK, if you leave my website, stop and go back. Only test my website, never click an external link, for instance. Or if you need to log in before you start testing, you can configure it and say, OK, this is the login page. First log in, then start testing. Don't press the print button or the delete database button or stuff like that. But still, I recommend using this only on testing environments, not in production. So this is the intelligent monkey. And there are a few open source products for that, which is Gremlins.js if you want to test a website, Netflix Chaos Monkey if you're a SOA, a service-oriented, and if you have a mobile application, you can use your Google UI application Exerciser Monkey. And yeah, to just a quick summary, it's quick and easy to implement. It will find bugs if you let it run long enough. But the question is, are those relevant bugs? Like, are those bugs that an actual user would find? Or if you have a lot of bugs, you want to concentrate on the other bugs first, right, and do them later. It's not really intelligent. Although it's called a smart monkey, it's not like really artificially intelligent. You can't train it. And as I said, you need sandboxing. So let's talk about the intelligence here. So it's like called smart monkey, but how smart is it really? Like, if you have a complex use case, like that, and you need a user to log in, and then I don't know, order some goods, and then he logs out, and an employee logs in and marks the goods as shipped, and then the employee logs out, and the user logs in again and checks whether the goods are shipped or whether he can rate them or whatever. So it's a complex use case. Well, the monkey will find in eternity, but maybe you don't have that much time. So how can we go about that? And I brought some analogy here. So there's a lot of talk about self-driving cars. And if you happen to have a self-driving car that operates on visual inputs, it, for instance, has such a scenery, and it needs to visually analyze the scenery to understand where it currently is, where it's going, what objects there are that it needs to avoid crashing into, what traffic signs there are, what traffic lights there are, which of those 6 traffic lights is responsible for my current situation, where I am, which lane and which part of the road, and what color has a traffic light, and all of this in real time, because it, doesn't help you if the car says, there was a red traffic light just a couple of 100 meters ago. And frankly, we can't solve that now. So this just too hard of a problem to do it in real time to be solved right now. And still Google has, self-driving cars. So what did they do? So if a problem is too big, such that you cannot solve it, you break it down into smaller ones. And this is what Google did. This is a car, you probably know that, it's Project Street View. And what Google did essentially is they drove around with it and took millions of photos and like terabyte of data and analyzed it offline with as much time as they needed, with as much calculation power as they needed, like the whole Google Cloud. And then they were able to map the location with much of what we wanted to know, right? And if you do that, the problem gets much simpler, because now you already, because of GPS, you know where you are, and you know what the rules are. You know how fast you can go, you know whether you can turn or not, or you have to go straight. So now you only need to find objects that you don't want to run over. And you already know that there is a traffic light, and you already know where roughly it will be in the image. Now you only have to check whether it's green, yellow, or red, and this we can do today. And we can do something similar with a monkey. So if this is too complex a use case for the monkey to find it out on its own, then what we simply can do is we can train it. We can, with a capture and replay tool, we can capture this use case and give it to the monkey. And the longer it is and the more complex it is, the more stuff you want also check. Right? You want to check what happens if I click back, what happens if I enter a different date, like a date in the past or a date far in the future, what happens if I order -1 items or 1,000 items, what happens if I, all that stuff the testers do usually. And now the monkey can do this for you. You just record one test and the monkey tests all the other like 50 use cases or scenarios for you. So, the trainable monkey bases on realistic use cases. It covers the corner cases. And the question is, what about coverage? So how do you know whether you tested enough, right? At what point does the monkey know whether it tested all the scenarios or tested enough scenarios? And we can actually, so this is still heuristically, right? So the monkey is not smart, like artificially intelligent. It's just intelligently designed. But we can make it that way. We can now use genetic algorithm to make the monkey smart. And what this means is, if you have like a use case like that, what the monkey does is, it, instead of testing that use case, because you already tested it, so it doesn't need to test this again. What it does is it creates scenarios from that, right? It changes little bits of the sequence of actions. And if it happens to find an interesting intermediate result, like if it certainly logs in as administrator, for instance, and then has additional possibilities, or if it opens an additional screen that it didn't know before, or stuff like that. Interesting intermediate states, right? Those states are not shared. Like, it starts from the beginning all over again each time it starts. And this is what we want to change. We want something. So if this is a search space, we would like to have a search that executes like this, right? That spreads into the open, and at every point where it finds something interesting, it creates another branch and boom, finds a crash. It would be a cool search, lightning search. And in order to be able to do this, we use a genetic algorithm, because the main feature of the genetic algorithm is, frankly, it's sex. You all know it, you all do it. Have you ever questioned why? Have you ever questioned why it is such a good idea to, mate, like genetically? Have you ever wondered that it's really costly, like not only for humans, but for like but biological cost. If you have trees that spread all their genes into the wind, or if you have bugs in the desert that wander about for kilometers just to find a mating partner, that it's really like costly to mate. And still, every higher developed organism on this planet mates. So it doesn't matter if it's a plant, an animal, fungus, or a human, which is an animal. We all mate. So sex is more than it is to the eye. And the reason being is that it gives us the possibility to mix character traits that were developed independently. So if, for instance, like speaking, very roughly speaking of a tribe, you have one tribe that developed a very good hearing and another tribe that developed a very good eyesight, you can have them combine, get offspring, which now has suddenly very good hearing and very good eyesight.
Or very bad.
Huh? Or very bad, which then is discarded by, the function of genetic algorithm. Hopefully. But this is the essential idea. Because if you do only cloning, like bacteria do, you only can improve on the very low level. Like, this is a single acid, and with a mutation, you only switch one of those individual acids to create a new gene, a new functionality. And it's very, very unlikely to happen. It can happen, but it's very inefficient, which is the reason why you want to mate. Not only for the fun of it. So to give you an idea how efficient it is, I want to introduce yet another example, which is Tower of Hanoi. For those who don't know the game, it's a mathematical game, and you have those slices of different size, which form a tower, and you want to move the tower from one position to the other. And there are two rules, which is you only are allowed to move one slice at a time, and at no point ever is a bigger slice allowed to sit on top of a smaller slice. This is essentially the game. And if you play this game with 6 slices, or here the animation has only 3, but if you play it with 6 slices, it's a solved problem, so we can very good calculate the numbers for it. If you do this with 6 slices, at each point in time, the smallest always sits on top because it's the smallest, and you always can move it to the other both positions, which means that if you, with 6 slices, you have 36 possible steps that you need to execute, which means if you do it randomly, like without any idea what you're doing, you have 2 to the power of 63 possibilities for this, which is quite a number. So 2 to the power of 64 is roughly the amount of atoms in the universe. Anybody calculated it? Okay, so it's 9,223,000,000,000 whatever. It's just a very big number, and it's very difficult for us to imagine how big it is actually. So what we do, instead we calculate it we transform it into time. So if we do 1,000 steps per second, it takes us roughly 300 million years to try every possible combination, which is quite a lot. And because if you do it randomly, maybe you're lucky and your first guess is already correct, which is, unlikely, but who knows. And maybe you're unlucky and the last guess, the very last guess, is the right one. So in the mean, on average, it takes you 150 million years. And if you let a genetic algorithm solve this problem, it just takes you 66 seconds. So this is the efficiency you gain from using a genetic algorithm for that kind of problems. And what we do with testing is essentially that kind of problems, right? Because with testing, what you do is you have a number of steps, like click there, enter there, click there, and it's the same as Towers of Hanoi. You just recombine them to find additional interesting states. So we can use a genetic algorithm to improve the search for, for the solution, and you can optimize it, for instance, on coverage, and say, okay, I want as much of the execution space covered, like of not the execution space, sorry, the code of the program covered. So generate tests that do this. So now you have the intelligent monkey, and it bases on realistic use cases, because another thing is that you can put those into the genetic algorithm, right? So it doesn't need to start randomly. You can train it. You can give it the recorded use cases, give it to the genetic algorithm, and it starts from there. It optimizes for coverage and is very effective. But maybe someone recognized, so far, all of this sounds great, but what can we find with this? What kind of problems can we find? Well, so far, we only can find crashes, right? So if all the bugs that Bob found during testing were functional bugs, well, this doesn't help us much, right? So how can we solve that problem? Which essentially is even a bigger question. How can we bring AI into testing? And this is a very hard problem. So, like one of the founders of Tricentis says, AI in test automation is a hype. Or one of the founders of Testplant says, AI in testing, I've not seen anybody doing it in a useful way. Because it's very hard. Why is that so hard? Well, the question is, can you spot a bug when you see it? Like, sorry? Do you see the bug in the picture? Well, there it is. That twig is a bug. It's an insect. Did you see that? And if we get to computer programs, this is a software. And if I ask you, is this value correct? Then you say, maybe. How should I know? Right, because you don't know the software. You don't know what parameters went into the software. You have no idea. You have no chance of knowing whether this value in that situation is correct or not. And the monkey has just the same problem. Okay, the monkey executes your software. It finds values, whatever. How should it know whether this is correct or not? And this is called the oracle problem. So decide whether it's right or wrong, correct or not. And, well, this is even a bigger problem, because even humans don't know. Because when is a bug a bug? Well, when it's not a feature. So management decides. And I brought some examples for that with me. Just to have a good laugh. So this is with Unix. Initially, they didn't have files. Like there was no, they had files, but they didn't have folders. So everything was on the top level. And then there were just too many files, so they decided to introduce a file system, tree structure. And then they introduced the dot and the dot operator, because it was command line, to reference the current directory or the parent directory, relatively. And the problem is there was a command called ls, list files, and it would just list those two operators as if those were like physically existing files. So what they did is they changed the ls command to add that line and said, okay, if the first, so for those of you who don't see, if the first character is a dot, ignore the file. Well, of course, you can name your file such that the first character is a dot, and then it won't be listed anymore. Which means by accident they implemented the hidden files. And probably, as you know, they still exist to this day, so this bug was never fixed. They just added the ls-a command to show the hidden files as well, because the system operators liked that feature so much. Then there was this arcade game where you had the spaceship, and you were firing at the aliens and tried. Sorry? Ah, okay, that's the name. Didn't know. Thank you. And the game was to, you know, kill all the aliens. And the more aliens you killed, the faster it was. And this also was not intended. This was a bug. Because at the time, hardware was slow, so the fewer elements needed to be rendered, the faster it was. So the game was faster the more aliens you killed, which was not intended, but they also never fixed this. And yet another thing is, you probably know Google Mail. When they implemented Google Mail, and you know the feature where you can say, your message has been sent, undo, like you have 3 seconds to undo the send, like, forgot the attachment, stuff like that. This also was a bug. So the problem with Google Mail was when they implemented the service or the product, they had a release date, and in Google everything is service oriented. So before the mail was sent, it was checked whether, you know, it was a valid email address, whether it contained viruses, whatever. So they checked a lot, and they couldn't get. So they had a lag. If you pressed send, it took them like 3 seconds to actually send the email, and they couldn't get it down. So some intelligent engineer just said, okay, let's make this a feature, and this 3 seconds you have to undo the send. Which takes me to the main point. Without specification, there are no bugs, only surprises. So, why do we test? Well, after you implemented something, if you have a new functionality, a new screen, a new feature, then you need to test in order to make sure that it works the way you intended. Like if you implement a calculator and you say 1 + 1 and the result is 3, then obviously this is wrong. And if you have a calculator that says 2 + 2 is 4, then that's right, right? So this is the initial testing that you need to do in order to make sure that the software works as expected, even if you don't have a specification. But this was not the problem that Bob faced, right? Bob had the problem that he already had an existing software with, say, 99 or 100 screens, and he only wanted to change one of them. And testing that one screen manually is no big deal. But if you have to test all the other 99 screens with all the use cases and functionality behind it, this is going to cost you a lot of time. And frankly, you don't even want to test this because you already tested it. It works. You just want to make sure that it didn't change, right? That suffices. You tested this at some point in time, maybe even 1,000 times already, and now you only want to make sure it doesn't change. So even after a change, the situation now is differently. Even if there is a bug, even in your software, 1 + 1 is 3, and it's been that way for 3 years. Software is installed at the customer. Customer is used to that. You don't want to change that. That is the correct answer. So if you just before a release, you have a new tester, he joins the team, and because he's new and you don't know what to do with him, you say, okay, go do regression testing. And he comes and finds you 5 new bugs. And you check and say, okay, this was there already a year before, this was there already a year before. You're not going to fix those bugs. I mean, you create a ticket, put it in your ticket system, and forget about it. But you're not going to fix them. Even so, I know about software that created recommendations for stocks, like for assets for bankers, and created a recommendation value. And during the mathematical creation, the calculation of that recommendation value, there was a mathematical bug, an obvious, like logical mathematical bug. And they fixed that bug. And then the bankers came and said, what did you do? Our software, the recommendation's not right anymore. So they had to put that bug back in. So if your customer is accustomed to having this as an answer, you cannot change this like randomly. You cannot change this without talking to him. This is the right answer, although it's wrong. And if the answer is 5, which is like mathematically just as wrong, this is not what the customer is expecting. this is the wrong answer, the other one is right. Which essentially takes me to the point that regression testing is not testing. Because with regression testing, you don't want to find new bugs. Which is the point of testing, right? So regression testing is to testing like a pet is to carpet. It just, sounds similar. Regression testing really is version control. Version control on the UI level. Because you don't want to change your software randomly. You don't want to change it without you noticing. If it changes, you want to say, all right, that's what I did. That's, what I fixed or what I implemented. I changed this. It's all right. You don't want to change it without you knowing. This is essentially what regression testing is for. It's not there to find new bugs. It's not testing. And if you do version control, and if you have 1 million lines of code, and you do change 3 lines, and you have a code review, then you're not going to review the 1 million lines of code, right? What you're going to review is just the difference. And you want the same, essentially, you want the same with regression testing. So if this is your application, it's very simple, and it changes, something on it changes. Like it doesn't matter what, if there's a value that's displayed, loaded from the database, whatever, and it changes, you want to get notified that it changed, and then you want to say, okay, this is a change, that's all I need to know. Everything else, all the 99 other screens, I don't need to look at, because I know they didn't change. This is all that's changed. I manually review the change. And what's even better, like with version control, you should be able to say commit. You should be able to say, okay, right, I changed this. Please update the test, maintain the test, just with a single click. This is what I wanted to do. This is what I wanted to change. And this is what the monkey can do for you. So the monkey doesn't know whether it's right or wrong, but it doesn't matter anyway. The monkey can record what happens. Like if your user clicks on that button, a new screen should pop up with all the values loaded from the database. And the monkey executes your application and records all that stuff. And after you make an update and change to the software, just replay everything and see whether it's still the same. Whether, clicking on that button still opens the screen and still loads the values. That's what you want to do. And this is what the monkey can do for you. And now the monkey can do functional testing suddenly. So, now you have functional monkey testing, and the battery is empty. I need to hurry up. So Oracle problems hinders AI, and regression testing essentially needs no Oracle. Sorry, can you put that in? I need the battery is drowned. Sorry. So regression testing doesn't need an Oracle. Okay, works. Because regression testing essentially is version control for the UI. And what does it mean for the community? Like, what does it mean for a tester? As a tester, do you know to be scared? Like, if artificial intelligence is coming into town, like, is doing all the regression testing, should that scare you? Are you going to lose your job? And the answer is no, because it just removes the boring part of testing. It removes the checking. It removes the click machine thing where you test the same thing 1,000 times again, where you have your checklist and it's mindless clicking through the application. This is what's gonna stop, and which means that the rest is gonna become more important. Suddenly, testing is a high-value activity because all the low-cost, low-value activity is removed. This is done by the monkey. Now, the tester becomes an expert in testing and in your application, because all the dump clicking is done by the monkey. So this is already, I was faster than I expected. This is already the essentials of my talk. So in summary, monkey testing makes it cheaper, faster, and better to test. and multiplies manual results. So you record a single test case and it gets multiplied by the monkey. And difference testing means that you make little maintenance, you have no wasteful testing, which means that you don't create assertions, like everything is checked, and therefore it's more complete. So we are creating a small startup for this currently, and we are implementing this as an open source product for different like all the different things that you want to test, results, whether it's a website or XML or PDF or whatever. And we're creating a Kickstarter project. So if you like the talk, I would love you to go to our website and register, and then at some point, you know, support our Kickstarter project. Yeah, thanks. Any questions?